Okay, here we are in the third part of the sets and probability uh, problem sets. And if you recognize maybe this problem from the last set, I put this problem here because I know some of you didn't finish. So if you've already done it, no problem. You don't need to do it anymore. First thing we're going to do is we're going to expand the sets here. So for example, set B, we can expand it, the integers from 0 to 5, not including 5. We just expanded it there. We expand set C. P is an even prime number. That's 2 is the only even prime number. Set E, we're going to expand into 0, 1, 4, 9, 16, 25, 36, 49 because it's all the square numbers less than 50. I'm not sure if they meant to put 0 or not, but we'll put it there. In this problem set, we're only going to do the odd problem, so A, C, E, etc. So we're just going to write down the numbers that are in each set intersection. So like the A intersect B would be 1, 2, 3, 4, 5, intersected with 0, 1, 2, 3, 4. The common elements there, the elements that are in A and B would be 1, 2, 3, 4. So that's what we put here. C. C intersect with D. So the elements that are in both C and D, they are in C and D. There's 2 and 4, 5, 6, 7. There's no common elements. So that would be the empty set. E. B intersect with D. So that would be 0, 1, 2, 3, 4. Intersect with 4, 5, 6, 7. Are there common elements there? Yeah, there's one element. There's 4. Moving on to G. B union A. B union A. So that would be any element that's in A or B. So that would be 1, 2, 3, 4, 5. And it would also be 0, 1, 2, 3, 4. And so if you put those together and not repeat any elements, you would have 0, 1, 2, 3, 4, 5. C union A. So that would be any element that's in both C and A. So that would be 2 or A. So that would be 1, 2, 3, 4, 5, right? Let's see. Decide whether each statement is true or false. Is A proper subset of B? That means, does A have only elements that are in B and have at least one element less than B? Let's see. A is 1, 2, 3, 4, 5, and B is 0, 1, 2, 3, 4. So no, those are not subsets of each other. So that's false. C is a proper subset of A. So is 2 a proper subset of 1, 2, 3, 4, 5? Yes, it is. It has at least one element less. What about C intersect D? So what elements are in both C and D? Well, there's nothing in both C and D. Okay, so that would be the empty set. Is the empty set a proper subset of E? No, because a proper subset is not a, or I'm sorry, a empty set is not a proper subset of anything, so we say false. Okay. Okay. Again, we are working only on the odds. So let's look here. Is F a proper subset of G? Well, let's mark F, and then we'll mark G. Wait a second, but G is smaller than F. If G is smaller than F, how can F be a subset of G? If anything, G is a subset of F, but not this way. Okay, so that's false. Is the number of elements in G complement equal to 8? Okay, let's mark G complement. G complement are these elements, that element, that element. Anything outside of G is G complement. That looks like more than 8, so that's false also. H union F, is that equal to G complement? H union F. So let's check out H union F. H union F would be, let's see, it would be these two, that one. Union F would mean that it would also be those, okay? is that equal to G complement? I don't think so, because G complement would be everything except for that. Everything except for that. So no, those are not equal at all. Okay, now how many elements are in G complement intersect H? G complement intersect H would be all the elements outside G. So it would be G complement intersect with H. H would be these three. Okay, so the intersection of these two sets would be basically H, right? Now, how many elements there? There's three, so no, not five. Okay, now moving on to number 2. List the elements of U. Well, U is just everything, right? So BDK, FECGH, I just listed all the elements there. Okay. Then it says list the elements of R complement. Well, let's see. First of all, what's an R? R is these four. So what is not an R? R not an R would be these four. So I would list GHKC. T complement. Okay, T complement. So what is inside T? T is these four. So what is not in T complement? What is not in T complement? BF and GH. Okay, so I listed those. List the elements of A. So the elements of A are these. Oops, I'm sorry. Forget what I did. B is, you got to be careful because that's marking set A, that's marking set B. These are not elements, okay? So what are the elements of A? The elements of A are these two and these two. So I would put QXWT. Now I'm going to find A union B complement. So that would be A union B complement would be A, and then let's find B complement. B complement would be everything outside B, which would be those. So the union of that would be, it would be P, it would be R, it would be Q, it would be X, W, and T. Because everything on here is either inside A or outside B. And that's, it's union. So now last one, A complement union with B complement. So A complement would be these two atoms here. B complement would be these here. I'm sorry, I did it again. I circled B there. Okay. B complement would be these three plus these two also. Now the union of those would be everything except for T, so that we just write P, R, Q, X, W, and then we don't have T, right? Okay, moving on. Okay, so we're just doing the odds again, A, C, G. So first we're going to do A union B and then union with C. So let's see, A union B, A union B. So if we took the union of both of those, then we would just basically be saying, okay, everything, because union is everything. And then if I'm going to do C, I would say, okay, C would be this. And then again, I'm doing union. So now if I union that together with that, then that includes everything again. So if I was going to do A1, I would say yes. It would be like all this, right? Okay. And then now I'm going to do 2. What if I did the other one first? If I put parentheses B union C first. So that would mean that, first I would have B union C, and then if I did union with A after that, I would just end up with the same thing again. So no difference. Okay. All right, now let's do this one. A union C and then intersect with B. Now this might be a little bit different. So we'll go A union C. And so that would just be, everything, right? Because union means or. And then I intersect that with B. Intersect with B. Now, an intersect means only the orange and the green part together. So let's see. That would just be this part, right? It would only be where the green and the orange part are together. So it would be this, it looks like a heart or lips or something. So I would just color that in here. Okay. Okay, then moving on. What if we did the C intersect B first? Would that be different? Let's see, C intersect B first. So C intersect B. So C intersect B. Okay, so C intersect B would just be this part here, right? Now I want to union it with A. So A would be this part here, right? So what's the union of A with this red part? It would be everything inside A and this little part here. Okay, so let me draw that. Okay, now moving on. We're going to do E. We're going to do A union B. And now I'm just going to go right and color in A union B because we've done A union B a lot. We know what A union B looks like. And then we're going to union that with C complement. C complement is everything outside C. So that's like that. So if we union the orange part with the purple part, you can see that the only thing that's not covered is the white part. Um, so if we were going to color that in, we would do it like it would be this, and plus it would be everything outside C. So basically it would be like that. Okay? What about if we reverse the order and instead we did the B union C, B union C complement first? So we'll do, okay, so C complement is just like, C complement is like a lot of stuff, right? Okay, and then C complement is that. And then we're going to union it with B. If we union it with B, we'll get also that little part there. Now we're going to union it with A. And once we union it with A, we're going to get that. It's the same thing, right? That one. Both of them are same. Now let's do G. So number one would be A union C. So we can just color that in. We're good at union now, right? A union C, and then we intersect it with B complement. B complement is everything outside B. And remember, we're just going to intersect it this time. So that means that basically anything that is purple or orange here, which is basically this part. Okay. So let me erase that and redraw it. Okay, so it would be this part. Okay. Um, and then let's do this one, which is first we do C intersect B complement. So C intersect B complement. So we'll color in C, and then B complement will kind of like draw in with this. And so what's the intersection of that? The intersection of those two would be, it would be this part here, right? This green sickly color. And then we're going to union that with A. If we union that with A, we get this. Oh, it looks a little bit different, doesn't it? Let me erase that. I'm going to redo it just so that you can see. So it would be all of A, and then it would be everything with C but not B. Do you see how it turned out different? So the order of operations here does matter sometimes. Okay. So that was the end of day 3.